stuff. You need a calculator, and you're going to need that chi-squared table again today, too. Okay. All right, so yes. The worksheets are due on Friday at the beginning of the class period. One of those, yep. All right. Okay, so what we're eventually kind of building up to in this lesson is to be able to do a hypothesis test for independence, to test whether two variables are independent or dependent of one another. In order to do that, we are going to start looking at tables of values first. So this goes back a little bit to previous math classes. We call it a contingency table in here. R by C is the order of the dimensions that you're going to be given. R is the number of rows, and C is the number of columns, and then each individual little area in the table is called a cell, just like when we use a spreadsheet. We have cells in our spreadsheet. We have two types of frequencies. Marginal frequencies are the sum of each row or column, so they're going to be off to the sides and at the bottom. Joint frequencies are the frequencies that you see within each cell, the interior of the contingency table. Okay, so joint frequencies are each individual piece. Marginal frequencies are a full row or column summed up. With those, we can find expected frequencies for a particular cell. Okay, so in a specific row and column location, and how they're going to notate that is E for expected frequency, and then R comma C. Again, rows are always going to come before columns, so if you saw like 1, 3, it would mean row 1, column 3 is the location that we're looking at that cell. What we're going to do is use the marginal frequencies. We're going to take the sum of that row, the sum of that column, and then we're going to divide by the sample size n that you have for that data value. And that would give you, within the table, we're going to have observed frequencies, but now we can also calculate the expected frequencies for each of those values as well. And then we'll be comparing those when we do our test for independence. Okay. So we're going to do an example of that first, getting those expected frequencies. It's going to look something like this. Okay, so here we are comparing favorite way to eat ice cream and gender, male, female. So the first thing we need to do, if it's not already done for you, which it will be for some problems, is you need to get the totals of each row, column, and then the total, which is going to be our n for this. All right, so again, a lot of calculator stuff today. So add up all our rows and columns. You can double check that I do this right. All right, 978 I get for the cups. 688 for the cones. 340 for sundaes. 88 for sandwiches. 103 for other. Okay, adding up across, I get 1,069. 1128, and if I add those together, I get 2197. I'm going to double check that the numbers across the bottom also add to 2197. So that's kind of a check within the problem that I added everything up right, and they do. Okay, so the totals of all the rows and all the columns should add to the same number. If they didn't, you'd want to go back and check that sum. All right, so that's our n, 2197. Now we want to find the expected frequencies for each way that a certain gender prefers to eat their ice cream. So, for example, if I were going to figure out the expected frequency of males that prefer to eat their ice cream with a cup, I would use this notation, E1, 1, the expected frequency for row 1, column 1. And to calculate that, I'm going to multiply the total of that row, the total of that column together. So 978 and 1,069 get multiplied together. Those are the totals below and across. And then divide by n, 2197. And we get 4, I'm just going to round to the nearest whole number for these ones, 476. Okay, so the observed frequencies that of males that prefer to eat out of a cup is 504. The expected frequencies are 476. Okay, so now you're going to do the same thing for the rest of the rows and columns. So row 1, column 2, row 1, column 3, row 1, column 4. Rows are across, columns are up and down. And then expected frequencies for row 2, column 1, row 2, column 2, row 2, column 3, row 2, column 4, and row 2, comma 5. All right, take a minute and get the rest of those expected frequencies. We can just round to the nearest whole number on these, okay? Yesterday, what the sum of all the expected frequencies is going to be. If I added up all these answers, what I would get. It's going to be our n. So all the observed frequencies add up to n, and all the expected frequencies also add up to n. So with rounding, you might be off by like an integer at the end, but you should be pretty close. This one, if I rounded correctly, I get exactly 2197. Okay, so it's worth noting, because we're going to have 2 columns of information when we do these hypothesis tests, that what you have in the table, the results of the sample, that is your observed frequencies, what we have at the top. And then the expected is what we calculate based on those percentages. Okay? Questions on any of that? Getting expected frequencies. Give you guys a second to double check those numbers. Okay. All right, so the U-try problem on the next slide, we're just going to skip that because you guys just did that one. So we'll just jump right over that. Okay, so what we have observed and expected frequencies for is we can do a chi-squared independence test now. A chi-squared independence test is exactly what it sounds like. It tests the independence of 2 variables, whether they're independent of one another or dependent on one another. We're going to use that same chart from yesterday. We've got 2 variables now, though, so we can't use K for categories. Instead, to get our degrees of freedom, we're going to take our rows minus 1, our columns minus 1, and multiply those together. And that will be our degrees of freedom that we're going to look for. So, for example, let's say you had a contingency table that was 3 rows and 4 columns. What would your degrees of freedom be? To calculate the degrees of freedom, we would just do rows minus 1 times columns minus 1. So 3 minus 1, 4 minus 1, 2 times 3, 6. Okay, and then that would be the value we'd look for on our chart with whatever our level of significance is. When you do a chi-squared independence test, your hypotheses will always look the same. Our null hypothesis is going to be that the variables are independent, and the alternative hypothesis is going to be the variables are dependent. Okay, so dependent means they have a relationship. One affects the other. Independent means they do not have a relationship. One does not affect the other. So it might be worded different ways when you see the claim, but if one affects the other, it means dependent. It means it's your alternative hypothesis, and then vice versa for the null hypothesis. The next slide has all of our steps of hypothesis testing, very similar to what we did before. Remember, chi-square, that shape looks like a right skewed curve. So it is always going to be a right tail test when you're doing these. Each expected frequency, same as yesterday, needs to be at least 5. If it's not at least 5, you can't do the independence test. So a lot of this is similar. So we're going to state our null and alternative, level of significance, degrees of freedom changes slightly for this test. We're going to find the critical value on the chi-square chart. The test statistic is going to be the same as what we did yesterday. The observed frequencies minus the expected frequency squared divided by E, and then you're going to sum up that column. Then you're going to see if that's in the rejection region or not, and then interpret the decision. Okay, so we're just going to do one of these. We're going to do this one here. I'm pretty sure there's some workspace on the next slide for you. Yeah, there is. Okay. So this is the ice cream example that we just looked at a second ago. And this has two things in it. It has, for each category, each cell, it has what the observed frequency was, and then it also has the expected frequency below it. And here they didn't round, they just gave, well, round as much. They gave it 3 decimal places, okay? So they kind of are keeping all the sets of information together when they do this. I'm just going to label each of those. O, E, O, E. And then we've also got all the totals. So if you have a problem, and you guys are going to have one problem on the worksheet, that's it for this worksheet, just one problem. It's going to look like this. You will not have the totals, and you will not have the expected frequencies yet. So for the hypothesis test, so you're going to have to do those first steps that we did on that first problem to be able to get to this point. Okay, so it's telling us here the total is 2197. The expected frequencies are in the parentheses. Our level of significance is 0.01. We want to, can you conclude that the variables favorite way to eat ice cream and gender are related? Okay, so the claim is that they are related. So are related variables dependent or independent? That means they are dependent. Okay, so that's going to help us write our hypotheses. All right, so my null and my alternative is the claim. Your alternative is wherever your dependent set of information is. So gender and way to eat ice cream are related or dependent. So then the null hypothesis would be they are not related or independent. Okay. We can also check here that we can do the chi-square independence test. Are all of my expected frequencies, my E's, greater than or equal to 5? All my E's are bigger than 5, all those numbers in the parentheses that we calculated, right? Okay, so we're good there. So we can do the test. That's our quick little check at the beginning. We have our hypotheses. All right, so now you're going to need to go to the next slide, and you're going to kind of have to flip back and forth here a little bit to get your table filled out. We're going to put all the O's and the E's respectively next to each other in the first 2 columns. All right, so 504, 287, 182, 43, 53. Okay, so that's all my info from row 1. Row 2, 474, 401, 158, 45, 50. And then just double check that you got 10 of them there. Okay. Expected frequencies, 475.868. 334.762. 165.432. 435. That's a 435. 42.818. 50.117. 2.132. 353. 8. 174. 565. Almost there. 45.182. And 52.883. All right. So this table, they kind of broke down the steps that you're doing to get that last column. The last column is what's important, what we're going to need to find the sum for to get that chi-squared test statistic. If you want to fill out the next two, the third and the fourth column, you can. I don't actually usually do it. We didn't do it yesterday. We just kind of did all that work in our calculator instead of writing it down. It's really tedious to do that and just kind of fast forward to the last column. So you're really just using that formula in the last column. You're going to take every O minus E, one row at a time, square it, and then divide by E. And then let's stick with rounding to 3 decimal places because that's what they're doing here. Okay, so for the first one, I would do 504 minus 475.868, square it, and divide by 475.868. And I would get 1.663 for that first value. And then you just do it 9 more times. A couple of those I gave 4 decimal places because I got a times 10 to the negative 4th power when I did my calculator. So, but if you have 0.001, that's fine. You could round it up. Okay, any questions getting any of that stuff? That's what takes a long time. All right, we need to get our critical value from our chart. To get our critical value, you need your degrees of freedom. Degrees of freedom are rows minus 1 times columns minus 1. Rows, how many rows across did we have, not including the total columns? We had 2 rows. How many columns did we have, not including the totals? 5. So you're doing 1 times 4. My degrees of freedom is 4. And then from the previous page, the level of significance we were given was a 0.01. So you can go ahead and find your chart. Find 0.01. Find 4 degrees of freedom, and I'm going to get my chi-squared critical value is equal to 13.277. If I want to draw that, draw my curve here with the right tail, always. And 13.277 is the critical value where our rejection region starts. Is 20.0665 in the rejection region? Yes. So what does that mean we do? We reject the null. Okay. So if we reject the null, is there or is there not enough evidence?
So there is.
There is enough evidence to, are we going to reject or support?
Yeah.
What was our claim? Yep. Support.
So why would you say reject the null?
So we always reject or support the null whenever we always reject or do not reject the null when we're making a decision.
Okay.
So when we reject this, we're saying, okay, that's not true. So therefore, this is likely true. Okay, but the decision to reject or not reject is always on the null, no matter where your claim is. Okay. All right. So there is enough evidence to support the claim that they are related, dependent. Okay. And that is a chi-squared test for independence. And that's it. We're done. Any questions? You have learned all of statistics. Congratulations. Well, not all of statistics, at least this class. All right. So we're not going to do another one because you guys are going to do it on your worksheet. They're going to get in a second. So homework worksheet, you guys got the 10-1 yesterday. That's 2 problems. The 10-2 that I'm going to give you in a second is 1 problem, 1 big hypothesis test. Both of those are due in my tray by Friday or earlier. Okay. You guys have the rest of the period now. You got 20 minutes. You have your last Math XL that's due tonight, 9-2. So if that's not done, let's say that's the priority right now. And then starting tomorrow, you guys just have time in class to work. You can get your worksheets done first if you want, and then exam review for 4 more days. And then the exam's coming up on Wednesday next week. So I showed you yesterday everything that's available in Polaris. You got the clue game. You've got your study guide that you got yesterday that has the list of topics. Remember, there's a Math XL that has a bunch of vocab stuff that you can play with if you want to review some of that. It's a little harder to do than the practice problems, but that's your choice how you use those next few days in class, and I'll be here to answer any questions you have. Do stuff on the board, whatever you want as we go through that. Okay? Questions for me? Yeah?
Did we do 9.2?
We did 9.2. That was the regression lines. Line of best fit. Yep. Should. Yep. We'll do that Monday. All right. I'll do cell phone lotto. The rest of the period is yours.
Oh, I didn't open it because
That'll do it.